Okay, I made a video about a year or so ago, I think, and it was a repair on an MG100HDFX head, which went okay in the end and sounded great, but the actual footage from the actual repair itself didn't come out. I taped it, but it just didn't happen. It got lost, it got damaged, it disappeared. So that half of the video wasn't on the YouTube post that I made. So what I'm going to try and do is, to the best of my memory, try and recall what actually the instigation that I actually did to repair the amp and get it back online. Because I noticed a couple of people have made a note of that. I didn't include that in the first bit, which is true, but it was due to unforeseen circumstances. But anyway, I'm now going to try and recap on that. And obviously, I don't have the amp. That was a customer's amp. It's been and gone. I've got a few photos of what I've done, stills, but I've got the original, well, a spare brand new power chip for that amp, and I'm going to try and just demonstrate, as I recall, the procedure I went through to fix it. Obviously, the first thing is to remove the chassis from the cabinet, get it on your bench, and you're going to, obviously, first of all, you're going to connect, see if you've got any sound coming out of it. Power on, hands careful, voltage, high voltage, be careful. Hands away, and easiest way to test that, just plug your guitar in through a lead, switch it on, make sure it's hooked up to a speaker of the correct impedance, and just low volume, and see if any sound comes out. And in this case, obviously, there was none. So first thing you do is that you have a really close visual inspection of the circuit board and all the components. See if you can see any dry joints, cracked joints, burnt components, anything that would tell you that that was the cause of the failure. If nothing is apparent, then you need to sort of do a little bit of audio tracing of one description or another. Probably one of the oldest and easiest methods of doing this is you don't have to use a signal generator. You do not have to use an oscilloscope. It's nice to have them, sometimes they're handy, but you do not need them. You can go much more basic than that. Your guitar and the lead and you strumming it is your signal generator. If you go online, there's plenty of videos and descriptions how to build a signal tracing kit like this. This is one I made from a Radio Shack mini amp, and it's got a probe, and all it can pick up is AC signals, so that's the sort of thing you get from your guitar down the line. So basically you can go, you've got your circuit board powered up on your bench, and being very careful, keep your hands out. You have the negative switched onto the chassis of the amp, and you can just go through, and you can follow the signal. It should be a low audible signal, so when you strum your guitar you should hear something that sounds like your guitar strumming, and get towards the actual power chip, which is at the back in front of the fan. Now I've got I haven't got the original one here, but I've made up a little look-alike one, which I've got here. And you can see this is a TDA 7293 100-watt integrated circuit monolithic chip, and this is what usually fails on this particular amplifier. It's got 100-watt handling capacity. It takes a lot of heat and a lot of punishment, and they have a typical short life. Well, it depends on how you treat your amplifier. If you run it like hell's bells, then they will have a short life. But this is usually the fault. I've done more than one of these. It's always been this that goes. So before we deal with that, I'll just look at the actual schematic. I'll don't know if this is clear to you, but with your amp switched on, you can check for power. If I remember rightly, and this is purely on memory, I think it might have been around 40 volts DC here on the power rails here. Plus and minus power, about 40 volts. Obviously, the other end of this probe was on the ground. Sorry, not with this probe, with a digital multimeter set to DC volts. I think it's roughly about 40 volts. I believe this power chip can handle about 50 volts. So I seem to remember it was roughly about 40 volts. It may be less. It doesn't really matter as long as you've got a supply there. You know you're on the right track. And you should be able to hear on the signal inputs here, down here, you should be able to, with this, with the signal tracing apparatus, you should be able to hear the sound of your guitar. If you've got the sound of your guitar coming through here when you're using the Radio Shack mini amplifier audio trace tool, that's good. And if you've got power on the power rails, that's good. You can pretty well sure, not for sure, but there's a good chance that everything that side before is working. Not always, but it's a good chance. So that leaves you with this 100 watt power chip, which is this TDA 7293 here, which is this little gadget here, which I've just mounted on a bit of scrap aluminium. On the actual amplifier, if I remember rightly, it sits on a big aluminium block, and the block is directly mounted to the cooling fan, if I recall. So another thing you want to check is to make sure the cooling fan is obviously working, that it's not, the fan speed is not slowed down to fail bearings, whatever, and that it's not clogged with dirt and dust. If it is got dirt and dust in it, get a little artist brush and clean it out. If the fan is not running very fast or is very noisy, see about changing the fan. These are not easy to change if they're failed. I'll tell you that now. There's 16 close pins here, and you need to desolder these from the board that they're mounted on. Now I haven't got an original board here, I've just got a bit of prototype board here. So you can see when they're fitted in there and soldered how close they are. So you've got to carefully desolder them, clean all the joints up, and then fit a new one. The original board that comes with, there's a lot of capacitors, etc., in close proximity that can get really hot, and they have a tendency to fail. Usually I check them and I change at least one or two of them. If sometimes I change all the capacitors on that little board. Let's see if I can bring it up on my Chromebook. It's around here somewhere. Let's have a look. There's one. Right there. Let's have a look. There we go. You can see there's a big connector block. I think about 15 or 16 pins on that, and several capacitors, some electrolytics, and a few sort of disc capacitors. Sometimes that board will be absolutely fried, and if it's fried and shorted out, not only will you have to put new parts in, including the chip, you'll have to fabricate the whole thing on a bit of proto board like this, and that is a pain. I've done it. But it is a pain, but it does work as a last resort. You used to be able to buy the whole unit down there complete, but I think that's long since gone. Another problem people make for themselves Probably because they don't realise. Assuming this is a chassis, ground, you cannot have this back plate of the chip shorted to ground. If you'll do, you just fry this chip straight off. Now, what I'll show you, a bit difficult to do this when you, I'll just undo that. I just put this together quickly earlier on just to show you a typical mistake people make they don't realise. Right. You don't really want to be handling these chips unless you absolutely have to, but this is only for test purposes. Hang on. Let's unscrew this. Right, as you can see, if you put a nut and bolt through there or a long screw and fix that to the chassis, that back plate is then shorted. So what there is a little bushing, a fibre bushing, goes in there. Then I think on the actual MG100 it's a long bolt or something, but for purposes of explanation I'll just use this one. Now you need to use some type of heat sink compound. There's many different types. Here's one of them. Thermal grease in a pump. You can buy it in little packets, you can buy it in pumps, but you need to put a thin layer of thermal grease all over here. Then you apply an insulating spacer on there. More thermal grease on here. And the whole thing then fits up to your mounting plate. Once you have all that assembled, you then need to use your multimeter set to see if you've got any continuity. They're usually on a buzzer if there is. You should have no continuity, it should be zero, no buzzing. If you've got that, you're pretty safe. If it makes a noise, you've got to take this to bits and find out where the short is on that back plate. It's very easy to do. Very easy to do. Only it takes a little spur of aluminium or whatever sticking through it. I'll go straight through that little thin plate, straight through there. So that's a common problem. I've seen that more than once as well. So if you can do all that, there's a good chance you can bring your MG100 back to life. You don't usually get a lot of other problems with them, but the trouble is that it's such a high-powered chip, 100 watts. It will easily be overloaded, overheated, and fail. And if it doesn't fail itself immediately, the capacitors around it typically will fail, and that will then blow up. As you can see from my main video I done a year or so ago, the repair was completely successful, and the amp sounded absolutely fantastic, I must say. Really, really good. Anyway, I hope this makes up for the video I never managed to make. Well, I'd make it, just didn't come out. But this is what you do, really, basically, and take it from there. And with a bit of luck, you'll get your amp sorted, like I've done with that one. Anyway, that's all for now. Bye-bye.